Welcome back, Chemistry Theory. This is part 2 of EQ 1.6. So we looked at adding stuff, taking stuff away, increasing concentration, decrease. Let's look at what happens with pressure and volume. If the system is at equilibrium and its volume is decreased, which will increase the pressure, the Chatelier's principle indicates that the system will respond by trying to reduce the pressure. So if you're increasing pressure, it's going to be trying to decrease it. Again, opposite. And a system can reduce its pressure by reducing the number of molecules that are present. And by that, we mean gases. Conversely, if you're increasing the volume by reducing pressure, it's going to shift to make more. Now, let's just take a look at something. We'll sketch something here at the bottom. So if I have, let's say this is a sealed container, and if I have gases moving around like this. Okay, let's say I have 4 particles of gas. And let's say reduce volume, which is going to be the same thing as increase pressure. So they're inversely related. So if I make that container smaller, all those 4 molecules are going to be hitting each other a lot. So if just like saying if you're in a classroom of 20 people and then all of a sudden we make the classroom 1/3 of the size, there'd be a lot of pressure, a lot of elbow to the teeth. So this would be the stress. Increase P. And of course, for that, in order to, the response would be, it says here, if you make a smaller number of molecules, so if these 2 molecules came together, and the other 2 molecules came together, then you just have 2 things bouncing around because these 2 join and then these 2 join. So you reduce pressure by making smaller number of molecules. All right, we'll take a look at the next page, more examples with that. So on the next page, if you take a look here, again, we're going to look at the ammonia example. So if I have something like this, if I increase pressure, which you can see, so it's a piston here with gas particles in it. So increased pressure is the same thing as reduce volume. So that's the stress. Okay. The response for that will be try to reduce pressure by making fewer molecules. So if we take a look here, with the ammonia equation, 1 nitrogen gas molecule plus 3 hydrogen gas molecules is a total of 4. That's an equilibrium with 2 molecules of gas. So to see which side would favor fewer molecules, 4 versus 2, 2 is fewer molecules. So this thing would shift to the right, because that side favors fewer molecules. So the side with fewer molecules is going to be favored here. So that's the way it would shift. So in terms of increase, decrease, products increase, reactants decrease, because things are shifting to the right. They're making more items on the right, which means using up reactants. Vice versa, if we look over here, if the stress was to decrease pressure, and of course that happens when you increase volume, the response will be, even though it doesn't seem like a stress, having decreased pressure, the opposite of that is try to increase pressure by making more molecules. So if the stress was decreased pressure, we want to try to increase pressure again, and you increase pressure by having more molecules. Just like students in the classroom, if you have 10 people, that's a lot less pressure than having 50 people. So in this case, shift will be to the left, because guess what? 4 moles or 4 molecules of gas versus 2, that side has more. So it's going to shift to the left toward the side with more gas molecules versus here in which we had fewer. So increase, decrease. So in this case, reactants increase and products decrease. Okay, so that's how gas molecules work. It has to do with the number of gas molecules, whether we want to increase pressure or decrease pressure. More molecules exert more pressure than fewer molecules. Take a look at this example. Describe how an increase in pressure, which is the same thing as decreasing volume of a particular system, affects the equilibrium. Be sure to state what the immediate response would be, the shift that occurs, etc., etc. So just kind of like a canned response here that shows what will happen. So let's say if I had increased pressure, which is the same thing as reduced volume, the response will be to try to reduce pressure. So it's always the opposite, right? The response is always the opposite, the stress. Shift to the side. So if I want this to happen, reduce pressure, shift to the side with fewer gas molecules. Okay, so the key thing there, if I want pressure to be reduced, I want to go to the side that has fewer gas molecules. And then of course, side shifted to will increase, and side shifted away from will decrease. Okay, on the next page we'll look at vice versa. All right, so what about vice versa? So decreased pressures, what would happen? So if the stress was to decrease pressure, and of course that is accomplished physically by increasing volume, increasing the amount of space the container takes up, the response will be to try to increase pressure again, slightly. So to do that, shift to the side. Now if I want this to happen, if I want an increased pressure to happen, to counteract the effect of the stress, I want to go to the side with more gas molecules. So I want to make more pressure. You want to go to the side that has way more molecules bumping around. And again, side shifted to will increase, and side shifted away from will decrease. All right, so that's how pressure / volume works. I usually like to think in terms of pressure. I find it a little bit easier. So what we'll do is we'll stop the video there, then we'll come back, look at the third possible stress, temperature, and then hopefully we'll be able to go through some examples using these ideas.